David, do you want to kick this off and get started?
Absolutely. Thanks everyone for joining this morning. Or joining if you're in Europe. I'm David Cerf. I'm the Chief Data Evangelist at GRAU Data, and I'm here with Floyd Christofferson from Hammerspace. Good morning, Floyd.
Hey, David, this is an interesting topic, isn't it? It's one that you and I have been talking about for 20 years now?
20 years. Yeah. Now I feel old. Thanks.
Anything I can do to help?
Yeah, it is interesting because the challenge does not go away. How do we make the most of unstructured data? This is one timely for every company out there that's driven by their analytics and by AI. Probably the real game changer is what AI is requiring in the way that we work with it. So excited to jump in here.
Yeah, no, that's right. And I think that's really the key point that we can start with is because, although we've been talking about hierarchical storage and data management, unstructured data management, for years, forever, the rise of AI has really changed the game and changed the landscape for, what is needed. And that's, we can see that in the industry trends, right, David?
Yeah, absolutely. I mean, you're looking at a change that is at a speed we've never seen, right? The adoption around AI has been so fast, and that puts pressure around everything in the way we think about our data and our data sets.
Yeah. So instead of data just being, I mean, before data was tied to an application, right? So an application would produce data, it would age downstream, and it would go ultimately into an archive. But the rise of AI, especially with LLM training and just the explosion of unstructured data, which comprises 80 or 90% of all data in the world, is that it's decentralized. And so if you're trying to feed LLM training but you're dealing with data that is distributed across decentralized data sets, different types of storage, multiple sites or clouds, then everybody is faced with these same problems with a renewed sense of urgency of what data do I actually have? It's a question, David, I've been doing this for years, and often I will ask an IT manager, like, what is your data? Describe your data to me. And then that's when but with AI, this is really, so what do customers really need, right?
Okay, not sure what I need, and maybe I'm not even sure where it is.
That's right. And especially if you're looking at, with the rise of AI in particular, where you have extreme high performance GPU computing requirements, this suddenly becomes really important because you need to be able to understand which data is relevant. You need to be able to access this data. But if your only choice is to copy it all into a net new high performance repository, that's a problem. And so really that's the focus of our conversation today, right, David?
That is. And the last item being cost is unfortunately what a lot of IT is driven by, right? IT is always about driving to zero cost. It's an expense center. And so that puts a lot of pressure on administrators to be able to meet the demand of the user, which is they really don't care about infrastructure, right? They're just saying, hey, I have a job to do, get my data to me. And the administrator who has to figure out how to make all that magic.
Right. And that's a really interesting point, isn't it? Because, we talked about the hierarchical nature of data storage in the past, data management in the past. And that's really because data storage is a cost center. But with AI, by being able to use LLMs or take your existing unstructured, structured, and unstructured, but in particular unstructured data, and actually get new value out of that, that becomes a now a potential new source of revenue for this data set. So instead of just being a cost center, but if it costs you more to move that into a whole new repository in order to realize that value, before you even are sure what that value is, you're stuck. And that's not a really good place to start, right?
Well, I think, and I think your point is that the pressure AI creates is that we now have to turn our data into. We used to be that, hey, we keep it, we might use it, and we thought there was value in it, but now we have the technology that lets us convert that into value for our business. And so the pressure is, how do you do it?
That's exactly right. So let's start from that first point of understanding which data is relevant. So what are the ways to even figure out what data is relevant? And this is really kind of the key point that we're talking about today, and that is metadata. But metadata is just information about your data, right? But there's multiple types. You've got your file system and object metadata. If I'm looking at my screen and when I see a file and a folder structure and so forth, I'm actually looking at the metadata that is presented by the file system on my computer. That includes where it is, the information, it includes all the kind of age and this typical information about a file. But that's just one piece of the puzzle, right, David?
It is. A file is fairly complex. I think we're all used to what you just highlighted, which is tell me the age of the file. But we really want to understand our data. But there's a lot of underlying information, and that's the contextual value that is generated. It's typically coming from the application that creates the file itself. So we could think of everything, whether it's a camera or it's a microscope, et cetera. These are generating these files. And they're generating both this content and contextual information that is critical for us to be able to better understand and utilize the pilot.
So if I take a picture with my phone, I not only have the picture, right, the file information itself, what size it is, what location, but that picture is going to contain that content or contextual information, such as GPS coordinates, right? Or if you've extracted other metadata, or an MP3 file, for example, a music file, it might have album art, it might have lyrics, it might have any number of different things, right?
Right. And the challenge with that type of data is it requires that you have to be able to open the file. This is not quite as simple to get to as file system metadata, which is pretty straightforward, but to be able to make use of content and contextual information means you have to understand the file itself and the schema of the data that's stored within that. So there's a challenge there.
Right, but there's even more information because everybody in most business environments in particular, if you've got data that is sitting on storage, costing the company money, there may be a budget associated, a department, a project ID, business rules for compliance or verification. All of these things are custom metadata, custom information that might be applied and managed on a spreadsheet. I've seen it on ginormous whiteboards where people are writing key information. All of this is also part of the picture, right?
It is. And your point is that there's a lot of this metadata could be in different places. So you have to be able to capture that like in a sidecar, or if it's a rich attribute. So these are additional elements that the user has generated that help them better understand what are they doing with that file. And so we have this very complex environment, all of it under the catchword metadata, right? So it's kind of like back in the day when we used cloud and it meant everything. Metadata, now that it's becoming relevant around AI, has kind of that same catch-all. And it's important to understand the depth that metadata brings to being able to use the data.
That's right. Maybe one way I can do that is to show an example. I like this example. If we think of a map, right? A map is the whole thing. You see, information about where you're going, what the environment is, distances, road names, place names, and so forth. But each of these are distinct, separate databases of information. So if we peel that apart, you can think of these as each individual silos of metadata. So your roadway information in GIS and other tools that would be listed in there. You may have place names and borders, physical boundaries, physical locations, road IDs, and so forth. This is another layer of information. Looking at these by themselves doesn't really give you a lot of value. And then you've also got your actual physical features. USGS is going to have topographical features, other types of things. All of these actually have to be aggregated together so that all of these different siloed sources of information can be presented and collated together, right?
And of course you could overlay more information, weather and topo.
So maybe so let me segue into, because this is an interesting analogy, but how does that relate to the world of file storage and kind of the topic of today? And so let me take a step and sort of talk, first of all, about how Hammerspace approaches this. And then what we can do is go into, how MetadataHub accentuates that and how we pull all this together, right?
Yeah. What does a map mean in my storage?
Exactly. So you think of your map as, part of your metadata, each storage, and then maybe this is a key point here, is that when we've talked about first that file system or object metadata, typically for the last 40 years, this has been embedded in the actual storage system itself. When people are going to get their data, they may be accessing it through standard protocols, but it's on the NetApp or it's on the Isilon or it's on some other storage. And if all you have is one storage silo, you're golden. You don't need to do anything else because all your data is in one place. The problem is, what if you add another storage? The old one retires or fills up and you need to add another one. Now you've got multiple access points. And you see the way that this expands out. And this fundamental problem is that your applications are separated from it. And so how do you deal with that? With these silos, now you've got to manage your data by copy. And so administrators are having to manage any number of point solutions for tiering, backup and DR, gateways to the cloud, replication to other sites. And all of these things, all of this movement is amassed across this fundamental problem that not only are the data repositories themselves siloed, but your actual metadata, the information about all of your data there is siloed. So what Hammerspace does is fundamentally flips the script. What we do is we elevate the file system out of the infrastructure layer. And this is with a standards-based high-performance global file system where now the users and applications are interacting directly with the file system, not going through all of these multiple layers into an embedded proprietary file system in the storage itself. And so by being global, it enables your orchestration to be global as well. So the way this looks is Hammerspace will what we call assimilate or extract the metadata from the existing storage wherever it is. The data doesn't need to move. The data can be on any storage. But what we've done now is created a high-performance parallel global file system, extreme high-performance capabilities that can saturate and match the performance of whatever your underlying infrastructure is. But look at the beauty of this now. From my users and my applications, I just see a file system. I haven't had to install client software. If I see a file system on my desktop on my computer or my application is looking for a file, it's doing through standard NFS, SMB, or S3 mounts, just as though it was on a single one of these storage silos. So anybody, anywhere can see everything. But don't forget, because the file system is abstracted from the underlying storage layer, it means that now we can orchestrate that data by policy, what Hammerspace calls objectives, declarative, objective-based policies that say that based on age of the file or other rules, I want that data to be placed here or there. But this is completely non-disruptive. A user, even with an open file, working on a file or an application with open files, those files can be in motion, live and in motion, without the user even knowing it, right?
You have this workflow that can be driven and all powered by metadata. So any metadata can drive these objectives. What's really cool about this, Floyd, is that you're solving a lot of problems on the entire infrastructure because it gets the more data we have, typically more complex, more vendors, we have more silos, on-prem and off-prem. It looks like you're bringing a layer of both transparency and optimization underneath the Hammerspace.
That's right. I don't need to put all my storage in a net new repository. If one fills up or I've got excess capacity on another one, I can seamlessly move that data where it needs to be. I'm not copying, even between sites, because the metadata is up here at the file system layer. When I'm not copying data anymore. When I move from one storage to another, or even to another site, we're instantiating the file essence, the ones and zeros on the actual storage media. But that file system metadata layer, that's the same file. So if you're in Oregon and I'm in Tahoe, and we're looking at the same file, we're looking at the same metadata, regardless of where the actual file essence is stored, right? And that's game changing. Nobody has been able to do that successfully at the performance levels needed for AI and high performance applications.
Hammerspace can use any metadata to drive the policy. What level of metadata awareness does Hammerspace have native?
So natively, what we're going to do is extract all of the file system, what we would think of as POSIX, but also object metadata, telemetry about the storage, where it is, and so forth. And then we can also apply custom metadata and so forth. But I think the point here is that there's also a lot of rich and contextual metadata, which was our second metadata point earlier. And that's really where MetadataHub comes in, right?
It is, and it's really driven by data-intensive industry, where we see a velocity of data that we've never experienced before. Things like in life sciences around genomics and in research, manufacturing, satellite, and autonomous vehicles. They're generating both massive volume of files in the millions to billions of files, and each of those files have their own complexity. Not just are specific file types to that industry and the vertical, in some cases, the proprietary file types, but those files themselves have a complexity due to the metadata that they have within them. And to be able to capture that metadata, you have to be able to open that file and understand the schema to be able to extract that. So what we're looking at here in the genomics file on the left is the raw metadata generated by the sequencer. This is a FASTA8 file. Then the challenge is that human beings can't read. So to turn this into something that is usable and into a structured form to where we can now make that data accessible back into some form that Hammerspace could do something with it, we have to extract it and then put it out or output it into a way that an application can use it. And so that's what we're doing inside the metadata hub, is that we're uniquely able to deal with these very complex file types that we see across various different verticals. So that the workflow that we bring is this ability to automate the ability to extract from the source, being the storage, whether they're file systems or object stores on-prem or in the cloud, and to be able to capture that metadata in an automated way and provision that to the data user in the application. And what we're creating is a metadata fabric. So the metadata hub connects directly into the storage, and we have read-only permission. So we're not modifying or changing anything within the file or the file system. We're purely harvesting this metadata, and we capture everything. So you can think of Metadata Hub as the single source of all knowledge, that we're going to capture everything everywhere, and we harmonize. We don't, again, change the metadata, but we make it to where metadata from different file types, different storage types, different user groups and business units, et cetera, can now, based on permissions, be able to access and query into that metadata, or more importantly, is to automate the output to feed data pipeline directly into those applications and port one of those applications, Hammerspace. So we can extend the depth of metadata that now can go into Hammers and drive the objectives. So there's two things happening in this image. The first is the ability from to provide context and contextual value into Hammerspace that creates a content awareness. So Hammerspace can drive its workflows, not just based on last access of file or age of file or some of the things that we traditionally use in the way that we would manage our storage, but we can actually use the content value itself to drive that and allow the users to redefine the way that they want to control their data and those workflows.
So Hammerspace has extracted the basic POSIX and file system metadata. So all of this enables this fabric. And then MetadataHub, in parallel, has extracted all types of richer metadata, all of the contextual and content metadata that you talked about, right? And so the magic is that enabling those two things to drive business outcomes through these metadata, enabling Hammerspace to move the data, place the data, again, transparently, so users don't even know it's happening. But all of this now enables all of your data sources and repositories to be one big data lake, even without, data lake is a loaded term, but one giant repository, virtual repository, because the file system is ubiquitous across them all, right?
That's right. And I think for clarity, the way to think of Metadata Hub is it's amplifying for customers that need that. Not every one of the Hammerspace customers would need this type of metadata extraction because it's really very vertical driven. But the available data that can be used to define how you want to look at data sets. So it's not just by the owner of the data anymore. We can now start to create very complex queries, which are required to be able to support advanced analytics and AI models. They're looking to understand in depth. I want file sets that are related to a particular cell type at a certain micron setting. This is the way user workflows. Now the user use their data, and you can now bring that level of definition into Hammerspace, so you can provide data product to them in a way that they could never have done it.
Exactly. I'll unpack that a little bit, David. So I'm a user. I maybe have a Jupyter notebook, or I've got project that I want to do. Walk through the type of use case and how they would actually do this.
Yeah, that's a great question, Floyd. So the Metadata Hub can feed into tools like Jupyter Notebook, Nime, and things like Snowflake and Databricks with metadata directly. The benefit for that is that metadata is going to be typically 1,000 times smaller than the physical file. So when you capture content in context, you can now directly provide that type of data that would service most of the data needs that a user has or the application without having to pull the file. So there's two things that can happen. One is you can address the query not having to physically touch a file and create that network recall. So because it's less data, you're using less CPU, GPU, so you can get better resource utilization. The metadata can now be queried instead of just doing basic search. You can actually now do contextual search, isolate data sets, and Hammerspace can now more effectively deliver the right data. I think what we're going to see going forward is that people are going to be looking to not just get all the data, but they want the right data. And that's kind of what we're seeing in the change around data quality. Is right. We're seeing this need to be able to provide better information. So this combined solution of MetadataHub and Hammerspace really is able to empower that user that they can start now and get this contextual search, content search, MetadataHub, ensuring the right data is where it needs to be through Hammerspace.
So let me replay that. So as a user, I may be looking at my global file system, a global namespace that spans all my storage silos, all data on all locations through these standard protocols. I'm seeing exactly everything, but that only gets me part way. Although I'm able to see everything, I don't necessarily know where the exact files I need are. But with MetadataHub now, I can now do the queries, the detailed queries based on just the specific attributes that I'm searching for. Build my job based on the results of that. And then with a handshake with Hammerspace, be able to trigger if that data needs to be orchestrated from an archive up into a GPU, into NVMe storage for processing, or if it needs some special protection for collaboration. then all of that can then happen automatically in the background. So it's this combination of the global view here, and then your specific detailed view of exactly the files and subsets of files that you need, correct?
That is absolutely right. There's one more use, and that would be storage utilization. Since Hammerspace is capable to optimize how files are stored. With the Metadata Hub addition to Hammerspace, Metadata Hub has extracted that content in context. The file itself can become an artifact. And that means that you can move it off that expensive storage. Now, the user doesn't see that because Hammerspace has abstracted all that with its global namespace and it's presenting the user view never changes. But the file now can go on to cheap and deep storage. That's the goal, is to better store and improve storage costs without it impacting performance and workflows. And then in the case that they need the file back, well, Hammerspace, of course, will serve that directly back from wherever the archive may be, on-prem, off-prem, or even this improved tape utilization. So this is really a way to better utilize the entire infrastructure. And so Hammerspace brings us storage utilization and economics that has never been available.
That's right. That's right. So, so sort of pulling this all together, this by aggregating and unifying the metadata wherever it is, all sources of information about the data, whether it's from custom business metadata that might be applied, whether in MetadataHub or in Hammerspace, whether it's the file system or object metadata, which Hammerspace would have extracted, or if it's the rich content and contextual metadata that MetadataHub may have extracted. Now we know exactly what data we have. We have complete intelligence about our data. We don't have to copy it all into a new location in order to have this global view of it. We know where it is through this universal metadata layer, right?
There's a new level of visibility that gives full transparency across everything through Hammerspace and metadata.
That's right. And that also ensures that you've got the right data, right? The quality of the data that you want, as opposed to just, throwing a shotgun approach at it. You can rifle shot directly to the data that you need, right?
That's correct. It's all, the thing that's worth mentioning, Floyd, is that to solve the AI problem on data quality, it's going to come from the capturing this embedded metadata. So to bring that to the surface and then have Hammerspace be able to use it, that really, I think, is going to continue this game-changing message making and accelerating way AI can use it.
That's right. And so if you layer that data intelligence on top of the storage intelligence, if you want to call it that way, of unifying all of the storage, whatever storage silo or platform from whichever vendor, whether it's cloud, on-prem, object, tape, high performance, flash, anything, all of that now is bridged with global file and object access, standards-based global file and object, because the key here is being able to see it all, but not requiring your users to go to another application. They just see it in their file system, right? And so this bridge of being able to create a global access and view sets us up for the really the key here, which is being able to automate the data orchestration. And this is really where this combination of file system metadata, which could be triggers, and the rich contextual metadata that could be a trigger, and any custom metadata that might have been applied from whatever source could also be a trigger, right?
Absolutely. And so your orchestration now has pretty much everything related to the file can drive, empower, and allow Hammerspace to ensure that your data is managed granular as you need. And I think that's where in these data intense verticals, it's been the big gap, Floyd. It's now changing that ability for them to manage and work within their data based on the current workflow. You're not trying to make them do contortion act to get to data. Hammerspace is ensuring that they can actually support the workflows, the access that they are expecting or demanding. And that brings a new level of access both from the file as well as from the ability to extract this embedded metadata, this access to their information. They can get exactly what they need when they.
Exactly. And I mean, you and I've been in this industry a long time and have been looking at the evolution of this going back. I don't even want to say how long it's been that I've been doing, but this is a paradigm shift. I mean, there's been initiatives through, I mean, back even to the 90s where you had, ILM, information lifecycle management, or digital asset management, or other types of things. But each of those was not able to do this because they didn't really know where all the data was across any storage or any vendor. They didn't have all of these rich contextual layers from the file system metadata, business rules, other things. And then even though they may have known what they had, and there's asset management systems that know what you have, how do you take action on that? And in a world where we need to be able to feed a GPU compute, but we don't want to, break the bank, or maybe those GPUs are sitting in the cloud. How do we get them there? So you want to minimize how much data you actually have to move. And so by being able to do this, by leveraging the intelligence of these multiple layers of intelligence, but then be able to do this non-disruptively is game changing. I think you'd agree with that, right?
Yeah, I think the timing is everything. And in this case, AI has created the demand to make use of all our data.
That's right. So this is an extremely interesting and timely topic. I think the key here and what differentiates this from the past is not only do we have the technology and the performance level, but we can do this in a vendor neutral way. I mean, many of the previous attempts to do this were locked within a vendor's ecosystem. In other words, yeah, you can know where all your data is as long as your data is in my proprietary platform. By being able to create a high performance standards base, I mean, everything that we do, I mean, when we're powering Meta's Llama 2, Llama 3, and now soon Llama 4, massive environments with thousands and thousands of GPUs, petabytes and thousands of storage servers, we're moving at Meta 12 terabytes a second, and this is all metadata driven. This is all, and so being able to have this all based on standards, no client software installed, no need to introduce new applications. It's all at this metadata level. And that is game changing. So being able to do it standards based, not locked into a proprietary vendor silo, leveraging the data you already have wherever it is, but then having all of these benefits on top, that's what we've been waiting for forever, right?
It is. And so for our customers, they can get in touch with our partners. We work together in the channel.
That's right.
Floyd, any other closing comments?
No, other than the fact that this is really a thought starter. And I would invite all of you to go to GRAU Data at graudata.us or hammerspace.com. You can reach out to David or myself individually. And we'd be happy to walk through, how this might work for you in your own environment with the specific applications and use cases you have.
Floyd, always good to connect with you and to push the boundaries. And I think this 2025 is going to be very exciting to see even better things coming out of both companies. So look forward to working with you.
Thank you very much, David. This has been great.
Have a great day.